Hello. So we just went through half an hour on looking at test corrections, and obviously I cannot record that because I then couldn't put the video up because some people have not done the test. All right, so with this one, what we're trying to do is we are trying to find the rate of change instantaneous. The instantaneous rate of change on this graph. So do we know what this graph roughly looks like? Concave or convex? It's convex, so it's going to look a little bit like this. And somewhere at a quarter, right? Somewhere at a quarter. Now I haven't, I might as well graph it. Let's graph it. So what was the function? 3x squared minus 2. Right, so where's a quarter here? So what are we expecting? We're expecting to get a negative result because at that point, we want the slope at a point which can be referred to as the slope at a point, the instantaneous rate of change, or starts with a D, derivative. All right, all of these things, boom. So here we go. Oh, were you going to say determinant? Oh, okay. Gave you the benefit of the doubt. Of a quarter, I'm going to pre-fill my limits. Okay, so here we go. F of x, we're writing 3x squared, take 5x, take 2, minus f of a. So this is f of 1/4. All over x take a quarter. Geez, who decided to do this? I get my 3x squared. So over here, so 3 times 1/4 squared minus 5 times a quarter minus 2. Yowza! Minus 49 over 16. Right? So that's going to become it's going to be minus 2. Where'd it go? Where'd it go? Up here. Minus 2 take minus 49 over 16. So it becomes plus. Okay, so we've got 3x squared, take 5x, and we've got over here, what was it again? Minus 2 plus 49 over 16. So minus 2 plus 49 over 16. 17 over 16. Oops. Okay, what's our game? So far, this has been the same thing over and over again. We see a formula, we're following it, it's telling us what to do. The most difficult thing was working out f of a quarter, but hey, our calculator did that for us, yeah? And now we go, because what is it that we're actually trying to do? Yes. I don't know what they just said. There's lots of... Right, we want to get rid of this x minus a quarter, but because we want to replace x with a quarter. Now, if we slap that in now, yowza, it's not going to be very nice, is it? So what we want to try and do is factorize the top to have a common factor of x take 1/4. But I don't know about you. Does that look a bit cray? And you go, don't like it. So what is it that we don't like? The fraction. So how can we get rid of, looking at this top line, how can I get rid of that? Divide by 16. You can times through by 16. And what you do to the top, you can do to the bottom. Now you could do that. You could pop that in your graphics calculator and see, I mean, if we've done everything right, it should factorize. I'm a bit worried to do it. I mean, who made this up, honestly? So if we go into polynomial, degree 2, 3 minus 5, thank you. I did! Remember this moment when you're older? And you can see that it sort of it can factorize it for you. If you're not happy with that, you can go back and, as we said, times through by 16 because you're technically only timesing by 1. Do you agree? Yeah. So I'm not going to finish that. Because the point of this is leading into 2-bit. Do you need me to finish it? I don't really want to. Oh, I'll do it later. The bit that I want you to talk about now is what happens, listening? So you've got the gist. You've got 2 options. You can use your calculator to factorize. It'll cancel. You can use your times by 16, again, use your calculator to help you factorize, and then they'll cancel. It'll all work out. Go back to our... Nope, that's not it. So, first one, we had f of x equals 2x squared at x equals 1, and bang, you went along and did that. What if I now said, ooh, change my mind. I now want it to be at x equals 4. And you have to do the whole thing again. Then I go, oh, yeah, sorry. It wasn't 4. I actually meant minus 4. Got to do it again. How annoyed would you be? Right, so lucky for us, we're going, and what happens if we just don't have a point at all? We're stuffed then, we can't use this, correct? So lucky for us, we have a second formula. So first principles when we don't have a point, and what we are going to get from this is we are going to get a derivative function. And it'll make sense once we've got it. Once you have that function, it'll be something x. And so then you can go, oh, well, when x is 2, sub it in. When x is 4, sub it in. Yeah? What's with the h's? Well, remember we talked about it being a point, another point being a certain distance away? Same thing. The h, it's just h units away. So you can see it is still coming from our, what's it called? Slope formula. Okay? Are we ready? Formula with the a in it only works if you have a point. So it's a little bit limited. If you're not given at x equals 4 or x equals 2, then we're stuffed. This one works every single time, whether you have a point or whether you don't. And you go, well, why don't you just teach us that one? Well, you'll see in a minute. It's nice. I love it. I normally just use this, but it is obviously, if you have a point, it's easier to work with numbers rather than x's and h's. Okay? Okay, so as I said before, you will be able to tell me that in one line eventually. You'll be able to just look at it and go, oh, it's this. This is the derivative. And then I'll run. Because you'll go, why did you make us do this long-winded version? Because it's in your course. And you'll appreciate it. So, we want to find it. The question would also say, using first principles. And as soon as it says that, you've got a choice to make. Are you writing down that f of a thing, or are you writing down this new one? And we're going the new one because we do not see a point. So it's f of x equals limit h tends to 0, f of x plus h minus f of x. See, I can't remember the numbers from the thingy, but I can remember this. Now, let's think logically, because maths is pretty much the same. I'm going to keep flicking back and forth, so if you're in mid-copy, sorry. Game plan. It's all about the game plan. Remember when we had this? we went, yeah, that's the thing at the bottom, and our game plan is that we actually want to replace x with a quarter, but we can't do it too quickly, otherwise you're dividing by 0. So we had to get a common factor of this on the top line. Well, guess what? Same deal. We eventually want to make h 0, because what we're saying is the gap between our point and the next point is going to be 0. We're getting closer and closer. 0 is going to be the gap. So that means we can find the slope at that point. So what we're going to have to do is cancel out that h. If you do everything correctly, you should have a common factor of h on the top line every single time. If you don't, go back, check your substitution, find an error. So here we go. We are just reading the mathematics. F of x plus h. What is that telling you to do? Sub what? Yeah, it says go to your function here, and wherever x is, we're going to replace it with x plus h. So it becomes 2 times, not x, but x plus h squared minus f of x. What is f of x? 2x squared. Well, that wasn't too painful, was it? I hope what you're thinking, my lovely maths teacher told me that we're going to have to pull out h as a common factor on the top line. Rot-roll. What's wrong with that, Scooby? Rot-roll, Shaggy. What's wrong with that? Doesn't have an h. Let's see what happens. You have to do something. What you gonna do? Okay, let's expand. I'll stop now and let you do it. I paused, now I'm back. Right, hopefully when we see x plus h squared, we know that that's x squared plus 2xh plus h squared. If you do not know that, then to the side, x plus h times x plus h, right? Do your little expandy, and you get that. But there is nobody in this room that will say, oh yeah, it's x squared plus h squared. Run for the hills if you tell me that. You know, leave that on the board, let the little year 9 see it and go, oh my God, that's so hard. What have we actually done? Not much. What now? Yeah, times 3 by the 2. Well, that's not really hurting my head. Always keeping in mind what we want. We want to be able to pull out a common factor of h on the top line. I'm almost about to jump for joy. Why is that? Because I've got 2x squared minus 2x squared. The things that don't have an h have cancelled out. This is looking good. Okay, so now I'm pulling out my common factor of h on the top line. So I'm left with 4x plus 2h all over h. It's that time that I love, especially if you guys have a different colour pen like I do. They cancel. Once you've cancelled, what is it time for? Sub. Sub. We make h equal to 0. So we say, therefore, f dashed of x, aka the derivative, what would it be? No, we're making h 0. We're not making x 0. What is this? h 0, gone. It's 4x. So f dashed of x is 4x. What does that mean? Let's call up our, we'll get that in a minute, but if it means at x equals 1, the slope will be 4. Now that is the very first question that I got you to do, I believe. Let's go back and look at it. Right, did we not get 4? Same one, 2x squared at x equals 1. The kicker with this is if I've now changed my mind and I've said, well, hang on, find out what is the slope at x equals 7. Well, it would be 28. And I will keep promising this, but you'll be able to do this exactly on your calculator as well. It'll just tell you what it is. Actually, let's do that now, because we want to say, how good are these calculators? So can you get your graphics calculators out? Sorry, just had a question. What happened? How'd we go? How did that disappear? We make h equals 0. And this, my friends, this is what we call our derivative function. Right? It's just the derivative. But if we're being very technical, it's the derivative function. Now, I just asked you, grab your calculators. They're going to amaze you with 2 things. One, they can actually draw it all in for you, but we're going to do it in the normal run mode. So your friend and mine that we've already played with, time of day. Looking this way. I'm about to do it. And now people on the video are going, why isn't she doing it? Because I have to get your attention. So here we go. We are going to go to option. And we're going to go to calc. But we're not going to go to solve n. We're going to go to this. D by dx. That is the derivative. I'm just doing, there's so many things I can't do it all at once. I'm just doing one. So this in here, we're going to put our function, so 2x squared. And what do you think you're going to put down here? The value of x that you want. So do you want to choose 1 again? So we can pop in 1 and we should get 4. Yeah, baby. We can go back up there. Oops. Use your arrow keys. And you could change it. Yep, 7. So what did we say it was? 28. Huzzah. They've done x squared up here. They've done x to the 4th over here. Please look. You have to expand x plus h to the power of 4. How are we meant to do that? How are we meant to do it? X plus h to the 4. Oh, you're breaking my heart. Pascal! Pascal's triangle. You better not say what. Who has never heard of Pascal? Oh, you have not lived. So remind me on Monday, we'll talk about Pascal. But you can expand. It means that you can expand x plus something to the power of 4, 5, 6 in one line. It's just the bee's knees. Okay. So, because you do not know Pascal, I want you to, I'll give you a little nudge in a minute. We're going to do x. And I'll tell you what x cubed is expanded. And you're going to have a go at question 2 for homework. Okay? So 1 and 2. And we're going to try and get 1A done before we go. Let's ride. F of x plus h. So wherever x is, we replace it with, because this is your f of x. We replace it with x plus h. So instead of x, it is x plus h minus f of x, which is x. All over h. Well, look at that. They cancel. We're left with h over h, which is 1. So therefore, f dashed of x equals 1. Now we're going to get a table on next lesson, and we're going to record all of these values because there is a rule that we're going to see. So please don't skip ahead. Will I make you do B? Yes. This is f of x equals 1. What does that look like? Y equals 1. It's a horizontal line. So what should our value be? 0. right? A horizontal line has a slope of 0. So you should be able to prove that it is 0. Yeah? And then expanding with this one, do the same thing. I've expanded x plus h cubed for you over here. Okay? I will save that to, it looks a bit messy, but I guess I'll save it to under lessons. But remind you, what is it that I want you to do? Question 1, we've done part A, so 5 questions for homework. I think that's being very generous of me. Thank you.